Upgrading your small 5-watt or 15-watt tube amplifier with a massive 100-watt speaker is actually destroying your tone. You bought a high-power speaker because you thought a bigger magnet and higher headroom would give you a premium professional sound. Instead, you got a stiff, sterile tone that completely lacks the smooth, natural compression of classic rock. You forgot that a guitar speaker is a heavy mechanical component that requires physical brute force to move correctly. Here at the Tone Manual, the physics shows exactly why this happens, proving that replacing your stock speaker with a high-wattage upgrade is the exact reason your amplifier currently sounds lifeless. Most guitarists blame their tubes, their overdrive pedals, or the size of their amplifier cabinet for a harsh and lifeless sound. The amplifier circuit itself is doing exactly what it was designed to do. You bought a high-power speaker expecting a premium sound, but the reality is you received a sterile tone lacking natural compression because a heavy guitar speaker requires physical brute force to move correctly. Resolving this issue doesn't require buying a larger amplifier, but it does require understanding a hidden ratio between electrical wattage and physical speaker efficiency. Many players assume that premium, high-powered components automatically equal superior audio quality, but the physics shows a very different reality. Most guitarists blame their tubes or pedals for this harshness, yet the amplifier circuit itself is doing exactly what it was designed to do. The circuit generates an electrical signal, but it relies entirely on the mechanical components of the speaker to convert that signal into moving air. When you pair a low-power amplifier with a high-powered speaker, the amplifier physically lacks the energy to move the speaker cone, resulting in a weak audio output that feels stiff and entirely unresponsive to your playing. Engineers have found that a low-power amplifier physically lacks the electrical voltage required to push an oversized speaker cone past its mechanical resistance. Therefore, you must understand the ratio between electrical wattage and physical speaker efficiency. Electrical wattage is simply the amount of power your amplifier produces, while speaker efficiency dictates how much of that power is successfully converted into acoustic volume. If you mismatch these two factors, your amplifier spends all its energy fighting the physical weight of the speaker rather than producing music. A massive part of the classic rock guitar tone we love doesn't happen inside the amplifier circuit, but rather physically occurs inside the speaker cone itself. Most pristine studio monitors are designed to reproduce sound perfectly without any added coloration, whereas guitar speakers are intentionally designed to be flawed and non-linear. The ribbed paper speaker cone is where classic rock tone is mechanically forged. When this paper cone is pushed to its physical limit, it stops acting like a perfect solid piston and begins to warp, adding a rich, woody character to your sound. Understanding this process requires looking at the internal components of the speaker. When an electrical signal pushes the copper voice coil, which is simply the wire cylinder that physically moves the speaker, the paper cone flexes and warps. This mechanical distortion is known as speaker breakup, and it smooths out harsh frequencies by adding natural compression to the signal. Think of it like bending a piece of flexible plastic. It yields under pressure rather than snapping. To achieve this desirable speaker breakup, your amplifier must output enough electrical force to actually bend the paper cone. The physics dictates that speaker designers must balance mechanical compliance, which is simply the physical stiffness of the cone and its suspension system. A speaker with high mechanical compliance is soft and flexible, meaning it requires very little electrical energy to move. Think of it like a soft memory foam mattress. It yields immediately to light pressure. A speaker with low mechanical compliance is stiff and rigid, meaning it requires massive electrical force to move. This acts like a solid concrete bench that doesn't bend when you sit on it. If you want natural compression from a small amplifier, you need a speaker with high mechanical compliance that easily yields to low electrical voltage. This brings us to the internal construction of high-wattage upgrades. A speaker rated for 100 watts is built with a heavy voice coil and a rigid suspension designed to handle high electrical current without tearing apart. Manufacturers must increase the diameter of the voice coil and use thicker, heavier materials to survive extreme heat and power. Because the moving mass is much heavier, the mechanical compliance is drastically lowered, resulting in a speaker that becomes highly stiff to protect itself from destruction. This creates a scenario known as the stiffness trap. Plugging a small 15-watt amplifier into this rigid system is exactly like putting a heavy-duty truck suspension on a lightweight sports car. The sports car simply doesn't have the physical weight to compress the heavy springs, and the consequence is a harsh and bumpy ride. In your guitar rig, the low-voltage electrical signal can't overcome the physical stiffness to achieve speaker breakup. Your 15-watt amplifier can't flex the rigid cone of a 100-watt speaker, and this physical mismatch completely eliminates the natural compression you're trying to achieve. If a manufacturer simply makes a guitar speaker stiffer to handle more power,
The resulting linear sound loses all coloration and incorrectly functions more like a sterile public address system. A public address system is designed to be perfectly linear, reproducing a clean signal without any distortion, much like a modern digital camera capturing a flawless clinical photo. A guitar speaker relies entirely on flexible, nonlinear distortion to generate musical overtones, acting more like a vintage film camera that adds its own grit and character. When you upgrade to a heavily overwound high-wattage guitar speaker, you're mechanically moving your rig closer to a clinical PA system, making your tone loud, accurate, and completely devoid of character.
High power levels also trigger power compression, a mechanical flaw where the highly conductive voice coil heats up and increases electrical resistance. When electrical resistance increases, the speaker is forced to draw less power from the amplifier. Think of it like a clogged water pipe. Pushing more water through only builds up heat and pressure, but the actual flow decreases. This consequence directly produces less acoustic output. As you push a heavily mismatched rig harder to compensate for the stiff tone, the voice coil heats up and actually begins to steal your amplifier's power, leaving you with a flattened dynamic response. Laboratory data proves that speaker sensitivity dictates volume far more effectively than wattage. Sensitivity measures how efficiently a speaker converts 1 watt of power into acoustic volume, which is measured in decibels. Human hearing responds logarithmically, meaning that doubling your amplifier wattage only yields a barely noticeable volume increase. The data shows that a high-efficiency speaker driven by just 10 watts completely outpaces a stiff, low-efficiency speaker driven by 100 watts. You don't need massive wattage to be loud. You simply need a speaker that efficiently converts a small electrical signal into a large mechanical movement. Resolving your sterile tone requires matching your low-wattage amplifier with a lower power-handling, high-sensitivity speaker, allowing the lighter materials to physically flex and generate the mechanical compression your rig needs. Prioritize high-sensitivity ratings over maximum wattage when selecting a speaker, because the right match lets the components work together rather than fighting each other. This principle applies whether you're wiring a physical wooden cabinet or selecting a digital impulse response in your recording software. The physics remains identical in both the mechanical and digital realms, meaning you must pair the power source with an appropriately matched load to achieve optimal tone. Most guitarists will spend thousands of dollars swapping overdrive pedals and vacuum tubes while completely ignoring the mechanical physics of their speaker cabinet. The speaker is the final physical boundary between your amplifier circuit and the air in the room. If you're pushing a massive 100-watt magnet with a small practice amplifier, you're suffocating your tone at the source. Inspect the technical specification label on the back of your own speaker cabinet today. Does your amplifier actually have the electrical voltage to overcome that specific mechanical resistance?